way, before we get too deep into this, if you want to follow along at home, if you want to go back and get hands-on and do some of this, I have built an example application. I have a detailed set of labs and notes and basically an entire free online course if you want to play with that. It is on my GitHub, github.com/Carducci/third-way-workshop. And it is basically a standalone course if you want to get hands-on and actually start playing with these things. And there are some things in the demo application that are a little haphazard. Pull requests are welcome, but overall, I think it's a good place to start, and I'm going to show you some of that stuff as we go through. Now, as you know, my name is Michael Carducci. I call myself a holistic software architect, and that's kind of, I don't know, that's sort of what, it's not really even what I do for a living. I don't really have a job. To paraphrase a guy named Dylan Beatty, I just do fun stuff and sometimes people pay me for them. So I guess it's a title, but what is this? What is a holistic software architect? I try to look at the big picture, but to go a little deeper, yesterday I mentioned, I invoked the name of Douglas Adams, author of The Hitchhiker's Guide to the Galaxy, and the sleeper, the underrated Dirk Gently's Holistic Detective Agency. What we are concerned with here is the fundamental interconnectedness of all things. The connections between causes and effects are often much more subtle and complex than we, with our rough and ready understanding of the physical world, might naturally suppose. That is a quote from Dirk Gently's Holistic Detective Agency. And when it comes to designing systems and making these key choices, we need to look holistically. We need to consider all of these interconnected things. And the reality is, the connections between these things are often much more subtle and complex than we do. And like Dirk Gently, when I come in an engagement, in a job, anything like that, I don't want to just give a solution. I want to solve the whole problem. And what comes out of this, I take this approach because, to paraphrase Dirk Gently, in software architecture, sometimes the trade-offs are much more subtle and complex than we might suppose. Every single decision boils down to this. What do we get and what do we give up to get that thing? And sometimes we don't appreciate what we're giving up. And I see that sometimes just getting old. And I don't know, you're older than me, Scott. Is this part of the process? That as you get old, the youngins don't even realize what they gave up. And in my day, the grass was greener.
Back in my day, let me tell you.
All right. But you know, I think there are some trade-offs, and I've really been spending the last several years thinking about where we got to with the trade-offs in the front-end framework space. Because as clever and as powerful as they are, these things have come at a cost. And sometimes the cost is worth it, sometimes it's not. And either way, in the process, we traded something revolutionary that we didn't think mattered. And the conventional wisdom tells us, well, this is just how it is. This is just how we build modern web apps in the year 2024. So I'm going to talk about a different way to build web applications. I'm going to talk about something called HTMX. And HTMX has the potential to radically simplify the kind of things that we want to do in web development, eliminate a lot of this bloat, a lot of this complexity, and a lot of this, honestly, this reality of opt-in tech debt in these front-end framework spaces that every so often, hey, we're going to change how everything works again, and you're either going to need to rewrite a lot of code or be out of date. I found out recently something like 68% of people are running unsupported versions of these frameworks because of this tech debt, of the constant churn of we're doing it this way, we're doing it that way. But I want to talk holistically about this because the thing that I think is interesting about HTMX is it's not just another JavaScript framework. It's a different way to think about how we build web apps. And it offers, I believe, a meaningful alternative to the complex status quo of all of the mainstream front-end frameworks. So I don't want to just do a quick start today, not just a tour of syntax. I want to introduce it in context. And in the context of the problems that we ultimately want to solve and the trade-offs of the various solutions. So I want to give you the tools to kind of evaluate it and think about it holistically for whatever you're doing for your next project. Because the reality is this for you? I have no idea. Maybe, maybe not. It depends. I always say, when do you want to use this? Well, if you want that modern dynamic feel without the framework churn. of, oh, we have a new way to do it again. We have a new concept for components again. If you've got a legacy application that you want to modernize and get that modern, dynamic, rich, responsive, interactive thing, it's a great tool for this without having to completely rewrite the front end and probably the back end. If you've got a team that wants to build this kind of app, but they don't have deep framework knowledge, that's great. If you have a team that does, they're like React people or Angular people or Vue people or Svelte people, then, use what you're good at. Take advantage of what you have. But if you don't, it doesn't mean you're out of luck when it comes to these things. Or if you just want a more, less maintainable option for doing these things. Now, like I said, if you're good at those frameworks, keep doing that. If you like them, keep doing that. If you already have an SPA, do not go away and rewrite this. If you really need that heavy processing on the client, if you need the smallest possible network payloads, or, resume-driven development is a reason to do things. Right? You want to get in that space and stay in that space, and you want to get a React job, then build a React app, because this will not get you there. But I want to talk about the web and how the web became an accidental application platform. So the web was designed for information. Like Tim Berners-Lee was not thinking about, hey, how can we create a new kind of thin client for all these applications we have at CERN. That was not the problem they wanted to solve. The web was about information. The web was about hypertext. And hypertext was just a radical idea just a few decades ago. And in the 1960s, Ted Nelson was talking about Ted Nelson coined hypertext, hypermedia, and he said this: a new form of writing appearing on computer screens that will branch and perform at the reader's command. A non-sequential piece of writing. Only the computer display makes it practical. But these two words, branch or perform at the reader's command. Now, this is accomplished with something called a hypermedia control. These little elements in the payload that say, hey, here's how you interact with a resource. Here's how you connect to another resource. Here's how you navigate in a nonlinear way, or send some data and get some data back as search results or whatever else. And so we had this evolution starting in 1945 when Vannevar Bush was overseeing a lot of the special research projects during World War II and just realized we have more information than we can manage. And he kind of half invented a hardware piece of furniture, a hypertext desk, which was wildly impractical. But it was a thought experiment. And 1965, Ted Nelson coins hypertext. 1968, Douglas Engelbart shows us the future. Like everything we take for granted, Douglas Engelbart and his team created and demoed in a real, actual demo in 1968. Including hypertext. In 1980, Tim Berners-Lee created something called Inquire. It goes through this all the way to the World Wide Web. And of course, at the same time, there was a lot of movement around SGML, Scalable General Markup Language, that could basically an approach to not only define the structure of a document, this is a heading, this is a paragraph, this is whatever, but also start to define these hypermedia controls. And one of the first controls we got in HTML was the anchor tag, the link. This gave us branching. And the second hypermedia control is the form object, the form tag, that gives us that interaction. And so the web has this concept of the resource. It's not really how we normally think about distributed systems. It's a little abstract, right? If I want to get the home page to my blog, I don't write some code in the console in my browser to call get home page or get page home or get blog home or get page one or any kind of the way I would think about writing method names. Instead, it's a resource with an identifier, and I just want the current state. And this is how the web works. You can go to any page, any site, anywhere you've never been before, and you don't need to do anything. It just works. So I make that request and I get a representation of the state. And the thing is, because that URI, it's an identifier. It's not an endpoint. It's not a function that I want to invoke. To the browser, it's just a resource. The browser doesn't know what a shopping cart is or a blog or a checkout page or a wish list or anything like that. It's just a resource with a URI as an identifier. We can link it, we can share it, we can save it, we can bookmark it, we can come back to it. So if I make that request, because I just want the state of that resource, it doesn't really matter if I'm getting it from my local cache, from a proxy server, from a CDN somewhere, from a web server, or one of many servers, right? I ask for it and I get a representation of the state back. And what's interesting is a lot of these resources, they're actually composite resources. They're saying, oh, hey, here's an image, here's a video, here's a style sheet, here's a JavaScript file, whatever else. And on the other side, if I want to create a resource, I'm going to post to an endpoint a representation of the state. And this is why we call it representational state transfer. A lot of times we think about this as part of APIs, but more broadly, it's the architecture of the web defined by, a handful of constraints. I talked a little bit about this morning, but the key thing is the affordances are how we interact with the resource, how it branches or performs at the reader's command. And that was incredible. That was powerful. That was something that we have as abundant as air that folks like Ted Nelson and Douglas Engelbart and Vannevar Bush could only dream about. And it's kind of incredible because HTML allows the browser to show us what we can do with any resource, any set of resources, without having to know anything in advance about the resource. So now we're in this era where we can connect and discover the world's information. Because we had the internet for decades, but the web changed everything because now we could find things. Now we could connect everything in these spaces. We could navigate it. It solved the resource discovery problem, which was a big deal back in the day, but it wasn't enough. Because a lot of this information was documents. What Tim Berners-Lee was largely thinking about to begin with was documents. And that's cool, right? Documents don't change very often. I write a document, here are my lab results, here's my this, here's my that, here's my employee handbook, I FTP it off to a server, and right, every time it changes, that's fine. But these are static resources. What about dynamic resources? In 1993, we put a web server in a Coke machine, a Carnegie Mellon, because people got tired of walking all the way across the quad only to find out they were out of Diet Coke. Or what's even worse than walking across the quad only to find out they're out of Diet Coke is to walk all the way across the quad, find out they do have Diet Coke, but they just refilled the machine 10 minutes ago, so it's warm. And so that web server would tell you the inventory and when the door was last opened. And so you had an idea of how long this stuff was here. The first webcam, the Trojan Room coffee pot. They created a webcam just because, what are the three hallmarks of a programmer? Laziness, impatience, and hubris. That's the laziness right there. I don't want to get up and have to make a pot of coffee. I'm going to wait for somebody else to make a pot of coffee. So they set up a little capture, and every 60 seconds, it would update a 128 by 128 pixel image of that coffee pot. So I could just look over there on the web in 1993 and see if there was coffee in the coffee pot and wait for somebody to fill it. And okay, now I'll get up. Now I'll take my break. And this was the beginning of a huge movement. Right around that same time in 1993, we started to standardize the common gateway interface, a way to connect a web server to your command line tools on your Unix or your, I guess, Linux system back in those days. It was around, but it wasn't taken very seriously yet. And we started to wonder, is this finally an alternative to the old style fat client architecture? Could the web give us a new thin client type of architecture? Because I can interact with programs. And we did. We did for a little over a decade at that point. In 1995, we got Cold Fusion. We got other server-side languages, PHP right around that time, for better, for worse, mostly for worse. I kid. It's fine. Right? I don't know. I don't know my audience well enough. If this is a place where I can make jokes about programming languages or not. I'm an equal opportunity hater because I've been programming for so long. I found the problems everywhere. But to be fair, you can do good things with PHP. It's just a forgiving language, and so it's also easy to do terrible things with it. And that's all we ever see. Because the stuff that just works happily, we never have to go in and fix. But for a little over a decade, this was the experience. And if you're old enough to remember the pre-Ajax days, like going to MapQuest and you would type in your address and nothing would pop up and say, oh, here's the rest of your address, because we already know we've got lightning fast caching and everything. You had to type it in, press the button, wait for the whole page to load, only to find out you fat-fingered something and it couldn't find it. It's like, did you mean this? Yes, click. And that was advanced UX back in those days. And then you get the map. And I look at the map, that's great. I need to see like 10 pixels over to the right, and I click the little, pan over to the right button. And it sends that request off and the whole page refreshes. And I'm on dial-up, by the way. And then it's like, I guess it was 20 pixels I needed to go. So I click it again. And 30 seconds later, I have a new page with that map moved over one more time. I need to zoom out. Click the minus button. 30 seconds later, I've zoomed out. So it works, but not well. But it's better than nothing, and it's still kind of cool. But this was due to a fundamental limitation in the design of the web, right? Fielding talked about this in his 2000 paper, that REST is designed to be efficient for large-grain hypermedia data transfer, optimizing for the common case of the web, but resulting in an interface that is not optimal for other forms of architectural interaction. We knew this. It wasn't designed for this. But it wasn't enough. And somewhere in the early 2000s, Microsoft had Outlook Web Access. And they thought, it'd be really cool if we didn't have to reload the entire page every minute to poll for inbox updates. So they snuck a little hack into Internet Explorer. A little ActiveX control, the XML HTTP request object. And they stuck it in there. And then that way, Outlook Web Access could go make little requests in the background and just say, hey, is there new messages? Is there new messages? And when the answer was yes, then it would refresh your entire page. Because otherwise, it was just a bad experience. And then, of course, the other browser vendors follow suit, and they kind of worked some version of the XML HTTP request into their browsers. And some bright spark at Google said, hey, we can do more than just a heartbeat. And they built this, and this changed everything. This was a revelation. I remember being at home in 2005. Have you seen Google Maps? Google has Maps now? So it's search and maps? Okay, right? I think we had just gotten Gmail as well. And this, being able to just drag that mouse around without waiting 30 seconds for every single little update. Everything was dynamic. This autocomplete, all of these things that changed everything. They came out with a glorious way to hack the browser to make it work the way we wanted it to. And there was no going back. Like, that was it. The die is cast. This is how the web works from here on out. It's a hassle. It's a pain. Because there are no standards yet on the APIs to manipulate the DOM. There is no standard implementation yet of an XML HTTP request. So they had to write all of this branching code. If this is IE4, if this is IE5, if this is IE6, may God have mercy on your soul, right? If it's Mozilla, if it's Netscape Navigator, I guess it was still around at that point. I don't know. It's been a long time. And I have no idea why it does that and then does that. But the thing is, that kicked off a whole timeline, because this is the Web 2.0 era now, where everything is dynamic, everything is wonderful. So we got a lot of these first-generation Ajax libraries like Yahoo User Interface Library and jQuery and EXTJS. And then we got client-side templating, and then we got reactive frameworks and component-based frameworks and single-page applications and micro front ends. And we're going full circle. I saw this, and I could not believe it. Like in the 90s, when we didn't know any better, I was building Visual Basic applications. When you click a button, it brings up the event handler. And I'm like, yeah, insert into the database and the button handler. And I'm ashamed of those eras, that era, when I was writing that code right in my UI, because why not? It's VB, The world is ending, whatever. And now they're doing this in a button, in a UI framework, and people are talking about, so I quoted Dylan Beatty. I think he's kind of a cool guy. He said, there's no idea in software so terrible that the JavaScript ecosystem will not eventually go, hey, we should get one of those. And it's like we're relearning a lot of software engineering lessons. So we hijacked the browser to become an application container. And we wanted these to be fine-grained. But eventually, these hypermedia controls just became UI elements. There is no hypermedia anymore. href equals fragment, empty fragment identifier, nothing. And then this gets even worse. So there's no graceful degradation anymore because it's just like, well, we're just doing it everything Ajax. If JavaScript doesn't work, well, you're used to the entire internet not working, so we're going to be no different. And then what does this even do? Like, I used to be able to look at a link and see where it goes, see what it links to. But this, I have no idea because this is buried somewhere else. We have no concept of locality of behavior anymore. And I want to point that out. Locality of behavior is not the same as separation of concerns. Like a lot of times we're just like, oh, this has something to do with behavior of this component, so I'm going to put it in a JavaScript file over there. Or I need to put everything in separate files, and that's the same as separation of concerns. But this is just a UI element now. It has nothing to do with hypermedia, nothing to do with hypertext. HTML, today in 2024, it's just UIML, user interface markup language. And in the process, like maybe that wasn't so bad, but in the process, we had to reinvent a lot of what hypermedia gave us for free because Roy Fielding defined REST by these constraints, and we violate at least 2 of them on a regular basis. But it works. So we got cool things. We got great apps, rich dynamic cross-platform applications, PWAs, modular code, entirely new markets and products, a more powerful and capable web. But we broke the hypermedia model. We broke the fundamental contract of the web. And every time we do that, things happen. Because we have no navigation anymore. We have no state. Oh, people are trying to bookmark these things and come back to them, and they just get an empty page. Okay, well, we need to invent something for deep linking. We need to reinvent that. And then somebody says, oh, well, our new site should be an SPA. Cool, right? Because I like Angular. And then one day, hey, our traffic went to 0. Yeah, you disappeared off the web. Why? Because when the spiders come to your site, there's nothing there. Oh. Well, let's reinvent server-side rendering just to get a representation that we can throw away as soon as we get everything down to the client side. We can render again for real. And over and over and over again, we gave up so many things. Now we have shorter-term business value capture. We have new security challenges. And to borrow a slide from the late great, the great Scott Davis, not late yet. To borrow a slide, right? Things are getting huge. And this is another reason we're doing server-side rendering now, so we can send something down to the client while we're actually loading several megabytes of code. Now, I love this. This is Margaret Hamilton. This is another that I stole from you. Now you're in here. It's kind of awkward. It's fine. I was hoping to plagiarize Scott secretly, and then he has the nerve to show up to my talk.
He'll talk with you later.
All right. Oh, yes, he will. Margaret Hamilton famously wrote the code that put a man on the moon. And somebody made a joke a few years ago. Gary Bernhardt. Do you know how long ago this was?
I don't. Years ago.
Years ago. And because somebody made a joke. Legendary Apollo programmer Margaret Hamilton next to a printout of the node modules directory listing for her first Hello World React app. And this guy Gary Bernhardt's like, is it really like just that much? How big would it really be? And he started doing the math. He's like, well, I ran Tokai, and it was 669 million lines of code in node modules of a newly created app divided by 49. That's because 49 lines per sheet at 11-point font for console list. It's 54,471 sheets of paper. If a sheet of paper is 0.1 millimeters thick, then multiplying the count by the thickness, we get 17.871 feet. Where are we today? Because that was years ago. I did the math. I ran Tokai node modules in the year 2024 on a newly minted Create React app, and it was 3.576 million lines of code, which is 72,995 sheets of paper, which is 73 meters of source code printing. So, for context, right? Margaret Hamilton, Apollo guidance program. Man on the moon, Hello world. For scale. Genuinely for scale. And here's the other thing. It's like, well, now we have 3.5 million lines of code, which introduce myriad security vulnerability vectors. And now we have to invent another thing to do all the tree shaking and pre-build steps and things like that, because we can't send that much down to the client. But we don't know what until compile time. It just gets crazier and crazier and crazier. And it is so hard to keep up. Yeah, according to Hero Devs, a company whose entire business model is saying, hey, you coupled to a framework that's been abandoned. You jumped on the Angular hype train a little too early, and then you built everything in it, and then Google's like, hey, yeah, we got this Angular too. And I know they have a similar sounding name, but trust me, they are completely different frameworks. You're gonna have to rewrite everything. Thanks everybody, bye. And that was how the announcement went, more or less. And even today, as the upgrade paths get easier and easier and easier, like Hero Dev's job is to help people deal with the legacy code that is coming out of these frameworks. 60.8% of companies are using an unsupported version of Angular in their tech stack, version 6 to version 14, that has no more support, no more security patches, and things like that. But it seems like the benefits justify the costs, right? We can't go back to the old way. We have two choices, right? Either this kind of progression towards modern dynamic web apps or the old clunky Web 1.0 UX. Unless there is a third way, and the third way is HTMX, in my opinion. And not just my opinion, actually. Let me summarize this entire first 20 minutes of this talk right here. Let's see if this works.
Hey man, look at this. We got ourselves a component. It's like a class with some lifecycle hooks. It makes building components easier. 1 year later. Hey man, we would never use some of these lifecycle methods. We're going to rename that into unsafe component will receive props. We use component did mount now. 1 year later. Nobody actually does that anymore. We're all about functional components, okay? So functional components are the way to do things. 1 year later. So use effect wasn't quite exactly what we thought it was going to be. So you shouldn't use effect anymore. We don't know what to use yet, though. 1 year later. React on the server is the greatest thing that has ever existed. It actually is good. Trust us. This will be the one. This is finally the savior. Sure, your server component can produce a client component which has a rendered server component which has a client component which has a rendered server component inside of it. It's not like it's going to be hard to debug or understand what's going on. This is truly the pinnacle of front end. 1 year later. So HTMX is actually a really great library.
So I stand here in front of you anxious because I'm talking about all this crazy stuff with the JavaScript ecosystem and all of it. And I don't hate it. I actually think a lot of the stuff is really cool, but I don't know if we always need it. I don't know if the trade-offs always make sense. I also don't think they never make sense. They do. But I am acutely aware as I stand here in front of you that while I'm talking about JavaScript frameworks, I'm introducing a JavaScript library. And a very legitimate question is, why should this be any different? Here's why. We look at this progression, all right? How we go from here to here to here to here to here. How did we get here? What was the problem? What was the problem that got us to front ends? Well, we realized that having large monolithic code bases can be problematic in distributed systems. Fair enough. So, and we got here because we got single page applications because page transitions are getting slow. Preloaded large sections of the application will smooth those transitions. So we did that to solve that problem, because the problem was we had these transitions were slow and all of this. And that came out of the component-based frameworks that came out of the fact that we have increasingly large code bases and we want them to be modular and manageable. Why are they increasingly large? Well, because we have a lot of boilerplate, because we're still doing a lot of, even though we got rid of the manual DOM manipulation, we got a lot of boilerplate. There's a lot of code in there, and we got to figure out some way to manage it. Why do we have a lot of code? Because we're doing a lot of imperative DOM manipulation, imperative all over the place, stuff like that. And we're doing imperative DOM manipulation because we need an optimized cross-platform JavaScript API for Ajax-powered applications and dynamic things. So it's like each stage, we're solving problems. We solve a problem, we introduce more. We solve a problem, we introduce more. We solve a problem, we introduce more. What is the problem? The problem is REST and HTML were designed for large-grain hypermedia transfer. We got two controls, two hypermedia controls, the link and the form. They're both large-grain. They're both page-level transition events. And almost everything in that Web 2.0 timeline originates from attempts to work around this fact. And I had a colleague that I used to work with, and the most irritating thing that he would ever do when I was presented with a problem is he would look at me and say, well, Michael, what would the solution look like if the problem didn't exist? What kind of fortune cookie wisdom is that? What? There would be no solution because there would be no problem because the problem doesn't exist. We wouldn't need a solution. Like, I didn't understand this for years. What would the solution look like if the problem didn't exist? Well, HTML would just be more powerful. Because we can build hypermedia-driven applications. We've been doing this for decades. OG HyperCard shout-out. Come on, were you expecting that at GIDS 2024? Okay, the one old guy in the room is just like, okay, yeah, HyperCard. Everybody else is like, what's HyperCard? We can do that. I'm not going to get into that. Don't suck me into that tangent. You know I will go down that rabbit hole, and we will never talk about HTMX. We just need a more powerful hypermedia. And what I like about this is it follows what Roy Fielding was talking about when he designed the architecture of the web. He had that code-on-demand constraint. And the code-on-demand constraint was not to turn the browser into an application runtime container. He said the advantages of code on demand include the ability to add features to a deployed client, which provides for improved extensibility. HTML's a little bit insufficient for what we need as a hypermedia. Code on demand, we can just extend it slightly, create a little superset, HTML extended. And to do this, it's basically a polyfill, a 14 kilobyte gzipped file, about 3,500 lines of code. So what's that? 0.00000%. I don't know. It's too late in the day. I'm under caffeinated at this point. But we dropped that in there. And
How tall would that stack be?
about yay.
About yay, baby.
Yeah, about yay. 2 centimeters, maybe? I don't know. I'm going to print it out and find out, because I could actually do that. It's definitely within a ream of paper. So here's a live example, and I've got the link here again. What I did, and let's see if this actually works. What I did is I created a little application, and let's see if I can, we can play around in here. So if we, lab 2 complete, let's see. There we go. Come on, don't. All right. So we'll run that. This is our application. So what I thought about doing was, my first thought, my initial thought, was, you know, it'd be a really great example to show this, this library, this framework, this tool, a to-do list app. Fortunately, I had a second thought because there are too many to-do list apps. I understand why people do to-do list apps now, by the way. A to-do list app is simple. I can write that in an afternoon. I spent like a week writing this, and it's not even very good. But, yeah, let's go here. This is it. It's an RSS reader. Back when the web was decentralized and anybody could publish, and you could curate your own feed. And when you curated your own feed of interesting people that you want to follow, and topics and creators and artists and writers and musicians, nobody was injecting a whole lot of advertisements, and here's a lot of random stuff that you didn't subscribe to, but we're going to show it to you anyway, just in case it gets you hooked, because we want to show you more ads. No, this is back when we were in control. Somebody once said something revolutionary that we should re-decentralize the web. Go look that up. Scott Davis has some interesting things to say. But it's a very simplistic RSS reader. You can subscribe to published feeds. It's a cross-platform MVC app. You can actually do the entire coding exercise in a browser. Thanks to Daniel Hinojosa, who taught me about getpod.io, and so everything is already optimized to work in there. And it's built using a server-side MVC framework. And what's really funny is these server-side MVC frameworks, it's not like we invented MVC in, what was it, 1976? Something like that. And then we just sort of stopped. Like, the frameworks are really good. We have components, we have partials, we have all kinds of modern things that we would still want to build these manageable modular code bases. A lot of the same, there are lessons going back and forth between the component frameworks, the client frameworks, and the server frameworks. We have validation, we have templating, we have pages, we have partial views, we have a lot of things in there. Better security controls, APIs, it's all there. But this is just a standard Web 1.0 application. And so I click and I wait and a page loads. I click, I wait, and eventually something happens. I go and I subscribe to a feed. I click, I wait. Oh, I see a little tiny spinner, something's happening. And eventually something happens. This is not... Oh, thank you, yes. Thank you, one person applauding. So there's nothing really kind of exciting about that. But it works. And in fact, if I disable JavaScript, it also works as well. But it's all there, low boilerplate. We get a lot of things. A lot of the things that we look at that we think are cool there, they existed before the client-side frameworks. And we end up with a stack called the Howl stack. And it's sort of a jab at the more opinionated stacks, like the mean stack, where it's like, oh yeah, you're using Mongo, Express, Node, and Angular. Or any of the other ones, I don't know, help me out. We were just talking about mean yesterday. It's hypermedia over whatever you want. I'm using .NET, so .NET Core has an MVC. You could use Spring, that's still around, people still use it. You could use Django, you could use whatever, right? They're all out there. Because when you're using hypermedia, it doesn't really matter what you're doing on your back end. So let's look at how we can improve this user experience. And the first one is, why do we replace the entire screen? Why do we have to replace the entire screen? Because when we do this, a lot of stuff has to happen. Code has to come in, right? We got to download everything. We got to go through and fetch all the JavaScripts. Then we need to parse them. And a lot of times we're just like pausing the parser to go and fetch something, and then we're pausing and we're fetching it and parsing and pausing. There's a whole lot going on. And I think I stole this slide from somebody. I don't know who.
The true cost of JavaScript, Daddy has money.
Right? Yes, yes. So one of the things we can do, and this is not what I would call an elegant solution, but it's an interesting solution. So if I go into my application, if I go into my kind of layout in here, go find one of these links. Actually, yeah, if I go look at the list of posts, and I go find one of these posts, and there it is, href post ID post read more. This is my read more link. So one interesting thing that I can do here, right out of the gate. Right out of the gate. I'm going to make a little bit of room so we can see. By the way, is this font size okay? More or less? More? There's a trick to do this. And that's not it. How's that? All right. So I'm actually going to start adding. So HTMX, one of the reasons I don't worry about all of the ephemerality of JavaScript frameworks is that you almost never code directly against HTMX. Like, unlike a lot, like if you're using jQuery or anything else, where you're doing a lot of JavaScript in the framework space, I don't even think about the JavaScript code. I don't write a line of JavaScript. It is all attribute based. So one of the first things I'm going to show you is an attribute that HTMX introduces. Somehow I managed to change my keyboard layout. Boost equals true. And when I run that, interesting things start to happen. And let me jump back over here. I'm going to jump back to this sort of main page. Hopefully everything has built. And I'm going to pull up my developer tools here. We're going to look at the network console. And I'm going to click on one of these things. So if I read more on this blog post, the first thing you'll notice is that this request is an XHR. It's not a navigation event anymore. It's an XHR that's been initiated by HTMX.
Michael, can you embiggen that?
Can I embiggen that? I am not sure. No, that's search.
Okay, never mind.
Yeah, I'll just talk you through it because I don't have developer tool foo. But one of the first things you'll notice if you are extremely farsighted, anything like that, or nearsighted, I don't know, if you have fantastic vision, is that navigation event was an Ajax call. So I'll jump back over here and talk a little bit about that, what just happened. With one property, I improved my page loading times. I've made that link an Ajax link. Now it's still a coarse-grained event, but it's not nearly as coarse-grained as replacing the entire page. So what happens when I add that attribute? It transforms a Web 1.0 hypermedia control into an Ajax interaction. It'll asynchronously request resource. One of the things it's going to do is it's going to extract the title from the head, and then it's going to replace the page title on the page. It's going to take the body out of the response, and it's going to replace only what's in the body tag, basically the body root. It's going to replace with what comes back. Now, is that the most efficient thing that we can do? No, of course not. But it's just the beginning, and it's also kind of indicative of how much you can accomplish with just that property. It'll push the URL into the history. So even though we didn't do a navigation event, it's going to push that into the browser history. So my bookmarking works, back buttons, forward buttons, everything still works. And then an option, there's another attribute called hx preserve equals true that will actually say, you know what, this thing, that thing, the other thing, I don't want to replace those, but everything else, go ahead and merge that all in. Now, we can do that. I also mentioned it's inherited. So if I go in here to my layout here, and I actually just add this all the way at the top of the button, then now every link and form on the page is boosted. So now everything local on that page is Ajax. And so just that, I'm starting to get some of that Ajax. I'm starting to get a little more fine-grained. I'm starting to get that dynamic thing that we've always wanted from the web. But we can do better. We can get a little more surgical. And so one of the things that we can do in here is we can use something called HX target and HX select. And you know what? I'm not even going to use notes. We're doing it live. We're going to live code this. And you're going to miss the best part because this is the... Scott, you can't leave right now. Live coding is the high wire act of the conference. No, you can go if you got to go. I'm only kidding. I'm just giving you a hard time. But we are going to do this live just because I feel like it would be fun to do this. And also, I just feel like y'all are so great. I just enjoy hanging out with you. And I'm not going to, no scripts. Let's just do it. So we can get a little more surgical. So let's actually do this. Let's go into our list of posts. And we're going to do a couple of things in here. So yeah, I could use this HX boost if I want to, but instead, I'm going to specify that this element is an HTMX hypermedia control. So it's dynamic, it's got the right granularity. So in here, I'm going to say this is a get operation. And so far, this is pretty much sort of mirroring but overriding what the link tag is giving us. But I'm saying I'm basically handing everything over to HTMX, which is really wild, by the way, because that is still a hypermedia control. So you turn JavaScript off, this still works. but it's just going to do it the old way. But so we've got that progressive enhancement and graceful degradation. So I'm going to say hx get is the URL, the relative URL to the post. And I'm going to say hx target equals main. So I'm saying, so normally the way this works with HTMX, if you have an HTMX hypermedia control and you click on it, and it's an hx get, for example, it's going to assume that what comes back is replacing the element. On our hx boost, it knows you're replacing the body. But what I want to do here is I want to replace the element with an ID of main. So I'm taking just that little piece out. Now, that's cool, except the way this is implemented, this is going to go off and get the entire page because I haven't gone in and kind of fine-tuned my back end to give me partial results. This is still the old Web 1.0 that I'm evolving as we go. And so I have two choices at this point. Option number one is I can go back into my controller and say, you know what, we're going HTMX full bore, and we're going to optimize all of our payloads, and this is going to give me a partial result. Not the whole page, but just the partial result. Option two, I can go in there and say, I still want graceful degradation and progressive enhancement, so we can use content negotiation or check for certain headers in the request and optionally give the full page or the partial. Or option three, which is a good option if you want to keep the back-end code clean and things like that, I can actually say hx select, and I'm saying only get out that main element. So I'm going to target the main, the ID, it's going to get the whole page back. I'm going to say put that in the element with an ID of main, and I'm going to extract just the element of main, and I'm actually going to specify that I want to swap the outer HTML. So it's going to completely replace that main element. And I wonder if this is going to work. I have no idea. But it's actually that simple that I don't super worry about how hard this is going to be as a live coding exercise. So all right, we've got it running. I'm going to go back to my index here, and let's just see what happens. Some kind of cool thing, I think. And yes, so just by doing that, it's modified. It has modified only that partial. So we're not doing the whole body tag anymore. We're doing just kind of this main area here. So we're keeping the navigation intact, the header intact, all of that. Now, one of the things you'll notice that I did is the swapping when I gave that hx swap. So hx target says, hey, I'm getting just a piece. I just want that dynamic, fine-grained control. I'm getting a piece back, and I want to put it in that element there without imperative DOM manipulation. And from that response, I just want to extract the piece to inject in there, and then I use this swap option to specify how I want this swap to happen. By default, it doesn't enter HTML, so it'll just put the contents of the response in the component that you're targeting or in the component that you turn into a hypermedia control. I used outer HTML. There's a bunch of options in here, but generally inner HTML, outer HTML is often quite common. And then there are also options that you can use in here as well. Bless you. So you can use a transition API. You can add some of these dynamic things. So you know, the swap delay, a settle delay. You can set up some transitions and things like that. And in fact, I'm going to jump ahead and just show you what some of these transitions start to look like. So I'm going to just cancel all this out. Jump over here and .NET run. And so let's see what this looks like now with the swapping, with the targeting, with the transitions. So some of the things that we can do in here. So for example, a simple thing, if I want to delete this, the way it worked before, I click delete, we wait, and then the page reloads, and now it's not there. We could do better than that. So, oh, I've got a confirmation dialog in here and everything. So I got a little spinner, and then it fades out of existence, and it hasn't refreshed any of the page. It just removed that element dynamically. Again, without any JavaScript in there. And the same thing going the other way if I want to add the feed, sufficient advanced technology./feed.xml. I've got my little spinner in there, and apparently I typed something wrong. Sufficiently HTTPS 2, yes, thank you. It's one of those things I've typed that so many times it's lost all meaning. And there we go. So we've got these very precise things happening. We've got the like that transition API, like setting that fade out, fade in, things like that. But one of the things you can do as well with your swaps is morphing swaps. So you can merge new content in. So it will say, hey, we've already got that, we've already got that, we've already got that. This is new, and put that in there. Now I've got to say with the Ajax select and the Ajax target, if you're getting the whole page back and then like throwing away 90% of it, yes, it's inefficient. Like I said, you've got options, content negotiation, HTMX aware backend with the request headers, or keep it simple. Sometimes it matters, sometimes it doesn't. Content negotiation, just how you can request certain representations of resource. And that was kind of the example I have here, accept text HTML, semicolon, HTMX fragment, something like that. And one other thing that we can do in these examples, because I'm doing that kind of partial replacement, the last thing that I can do in here is the Ajax push URL equals true, which will update your history, the URL location, things like that. And it kind of goes back to the feedback, that loading is a journey thing. One of the first things is something happening? Now you'll notice when I jumped over to the final state of this application, I get all kinds of feedback. If I subscribe, I've got some kind of spinner loader as things are happening. You'll notice when I was kind of pressing any of these buttons, yeah, okay, I've got validation on here as well for free, by the way. There's no beyond HTMX and whatever is shipped with Bootstrap. There is no JavaScript in this application. XML, and just the same thing. The way these things are swapping out, it's just a set of attributes to kind of make this come back. So one of the questions is, when we look at HTMX, why do we have to replace the whole screen? We don't have to. Another question the authors of HTMX said, why only get in post? And that's a great question, by the way. Am I right? Because HTTP, the Hypertext Transfer Protocol, the thing that's for HTML, supports get, put, post, patch, delete, options, head, trace. There's a whole bunch of them. What does HTML stand for? Or what does HTML offer? Get and post. End of list. If you want anything else, you have to write JavaScript. And so, but why? Like if I want to build this to sort of RESTful way, couldn't we extend HTML to give us access to the other three methods? And so that's kind of another interesting thing here. So in fact, if I jump back to the feeds, I did the exact same thing in here. There's my submit button. And a lot of things have kind of happened in this code. Right? It's a submit. It's got a class, an ARIA label. I'm really sad that Scott's not here to see that I have that in there. But Daniel, you'll tell him, right?
What's that?
That I've got the accessibility stuff in here.
Okay.
Yeah, because I was hoping, I wanted to impress Scott, but it's already there. Title, whatever. All right. But here's what I did. So earlier you saw me do an Ajax get. This is an Ajax delete. So I'm saying I'm doing delete operation on this resource. And it sends a delete request instead of a post. And then here I'm saying, yeah, I'm getting a 204 no content back because I'm doing delete. Delete doesn't give me any content back. And I'm saying, take that content and swap the outer HTML and delay a second. And then I've got to confirm in here. There's other ways to do this. This is sort of the basic bare metal way to do it. And then I'm saying, oh yeah, when I click on this, disable the element as well. But this is doing a delete operation now. We have the whole spectrum of HTTP request methods in there. And then I've got the transitions and things like that in there as well. So there's a couple different ways to do this. Because I'm doing a delete operation on this, I don't really need to. I have options. I can apply this to the form, that the form is doing a delete if I wanted, or I can make just this button be a hypertext element, which is another option, a choice that I made here. But if I put, if I change this method, or if I add the HTMX properties on here to the form, and I'm doing a post, or a put, or a patch, it's going to it's going to automatically include my parameters. If and in fact, that's my next slide in here. So you can enclose forms. Now, by default, it's not going to include it's not going to include all of the enclosing form for GET requests, but it does include the form for all other types of requests. So by default, if I put something in here, it is going to include, so you can see in here a button, HX post. That's going to include the closest enclosing form here. So that's going to pull all this stuff in here of whatever's in there. It's not going to do that for a GET, but it's going to do it for all the other types of requests. Another way that we can do this is we can actually just say, hey, include all of this stuff in here, which is really what we're doing here. It's an HX post to context, target is main, include hash search, like the element with the ID of search. And another way we can do this is actually create some inline values. You can actually generate these with JavaScript if you want to. Another one of the things that came up was, all right, so HTML, you have to replace the whole page. Not anymore. Okay, why only get and post? Well, we have access to all of the request methods. And one of the third things we have in here is why are only anchors and forms? Why are only anchors and forms hypermedia controls? It would be better if we could make anything a hypermedia control. And so that's actually what we did here in this page. This little span that is giving us a badge, and in fact, I'll pull that up very quickly. This little span in the navigation that's giving us a badge, that span is now a hypermedia control. And it is giving us that that unread count. And it has not updated, so let's refresh that. So basically, I added the HTMX properties to a span, and that makes it into a hypermedia control. Yeah, here it is, the all unread count. And anything now can be a hypermedia control, any component. So the other thing that's kind of interesting about all of this is, why are our events only click and submit events? We might want anything to be able to be an event. So in fact, this element, this span that is an unread count, it's triggered on load or when a post is read. And so I've got custom events that are being bubbled up in the browser's event bus, but I've also got all of these lifecycle events like a load. So for example, if I jump over to here and I actually read one of these posts, because now we're only replacing that main section there, when that loads, you can see that decrements. So because that page loading, it emits an event. And HTMX gives us a lot of non-standard events in there. We've got some trigger modifiers in there. We could say we want this to happen once or only when something's changed. I've got some notes in here on the extended CSX connectors, but really wrapping it up, right? The ideas are any element should be able to make HTTP requests. And we accomplish that with these 5 properties. Any event should be able to trigger a request. Any event, any HTTP action should be available, and any place on the page should be replaceable. I've got the whole exercise to go into. And so, we covered this because I said that kind of controversial thing that you're kind of opting into tech debt with some of these frameworks. Are we still not doing that? And I think the thing is, it's all declarative. It's not imperative. And that really starts to change the game. And what about these breaking changes? Well, I put this into production in my CRM with 1.9, and when I looked at what was happening with the 2.0 release, big major point release. So the what was it? HTMX is about yay. This is one page. That's her entire migration guide, and it required, in my case, in most cases, 0 code changes. I'm using it in production. I run a SaaS CRM for professional entertainers, and it is taking this application that would take a couple of seconds to load a page. Most navigation events now, because it's all dynamic and doing these things, fetch HTML less than a millisecond. Parse the HTML, a millisecond. Parse the scripts, 13 milliseconds. Render, 22 milliseconds. Paint, 4 milliseconds. So to load this dashboard now, it went from 3 to 4 seconds to 360 milliseconds. Like, it is the kind of experience that people want. And I don't have a lot of JavaScript to maintain. In fact, I only deleted JavaScript in the process. So there are some things that I ran into running this in production. Number one, and this is, I think we're at time, right?
Yep.
Yes. Thank you. So I will say this. HTMX is processing responses. This, if you look at this, anytime I am, like most MVC frameworks, multi-server-side frameworks will automatically sanitize everything you merge into a template. Unless you do something like this, html.raw. And we all know when I'm doing that, utils.sanitize. But the other thing that you want to do is run this hx disable equals true. And that tells HTMX, do not process anything there. A lot of other kind of cool things on here. I've got more resources linked in the slide, but we're at time. So check out the repo if you're interested, and you can walk through a whole day's worth of exercises. Thank you.